point, let's look at the standard deviation. So the standard deviation, we should already know this, right? This is standard deviation of x. This is the square root of the variance of x. And this is just e of x squared minus e of x squared. Okay. So e of x we already know. So e of x is equal to 1 over p. We're good. How about e of e squared or x squared? So let's kind of look at that. And actually, this is basically a very similar thing, right? So here we end up getting x is equal to 1 to infinity of x squared. Remember, we do the function here, so x squared. And then we just do x is equal to x. So here, at this point, we should be okay with what this is equal to. This is just q to the x minus 1 p. So, and I can pull the p in front, right? So I'll just bring the p in front now to kind of help. So at this point, the question then becomes, well, okay, what is this thingy, right? And basically, we're going to do the same game as before. So let's, and at this point, this one is definitely a little harder. It's not something like, I wouldn't ask something like this on an exam. Maybe on a homework, but definitely not exam, because this is much more, it takes more time. And so let's kind of figure this out. What is this formula? So this formula, so let's first see what this is. We'll do i's, since we normally do i's for this, to kind of differentiate the two. So here we get 1 squared times q to the 0, plus 2 squared, which is 4 q to the 1. We'll just do that. 1 times q to the 0, plus 3 squared is 9 q squared, plus 16q cubed, etc. And I want something that's going to be close to what I have, right? Well, okay, what is something that is close to what I have? Well, let me try multiplying by q and seeing what this gives. At least I might get closer. I don't know. So this is just we add a q everywhere, right? So let me keep everything in the same columns just as before to kind of see what this does. So here I get 1q plus 4q squared plus 9q cubed plus etc. So if I then take this and I subtract this, this gives me 1 q to the 0 plus 4 minus 1 is 3. So I get 3 q to the 1. 9 minus 4 is 5. 5q squared. 16 minus 9 is 7. And at this point, you should probably see a pattern. This is just the odd numbers. And this one, it's basically saying, okay, well, if I have the odd numbers, what I want to do, you can kind of see. So this is just 1 minus q, right? 1 minus q of our summation. Okay. What do we kind of know? Well, we kind of know that, well, we want to get rid of almost everything, but not everything, right? So what is the formulas we kind of know? We know that, so I already have the answer because I did this before. So this should just be equal to, I'm trying to see whether, yeah, so, okay, so how do we do this? So one of the things is I'm going to note is I'm going to notice that I'm missing all the even ones, right? So if I recall this formula, right, I times q to the I minus 1, this is just equal to q to the 0 plus 2q1 plus 3q squared plus 4q cubed, etc. But I want to get rid of just the even ones, right? So I'm going to multiply with this by 2. So what this is going to do is it's going to do 2 here, 4 here, 6 here, 8 here. And then I want to remove from this so this is basically everything here, right? So I have almost everything. But I have to remove some things, right? So now, like, notice here how I have all these numbers plus 1, right? So I need to subtract 1 from each one. So I want to subtract 1 from each one. So when I do the subtraction, so let me write this down. This minus this gives me q to the 1, q to the 0, plus 3 q to the 1, plus 5 q squared, plus 7 q cubed. And notice how these are the same. So in other words, this thing here, so this implies what we have. So I know it's super complicated, but these are basically how we do things normally. Like, welcome to math. It's a lot of problem solving. So we have, what was my formula? I had 1 minus q sum I squared q to the I minus 1. So this we showed that this is equal to 2 sum I q I minus 1 plus, or no, so minus, so I equals 1 to infinity, I equals 1 to infinity, minus I equals 1 to infinity of q to the I minus 1. And these ones on the right, we already know these answers, right? So 2 I q I minus 1, this we saw is equal to 1 over p squared. So we get this is equal to 1 over p squared. On the right, we already know this one as well. We know this is equal to 1 minus 1 over p. And this part here, we know this is equal to p. So I can just divide everything by p. So our summation that we wanted to solve is 2 over p cubed minus 1 over p squared. So here I divided by p. So yeah, so let's actually put this into one formula. So I get 2 minus p over p cubed. Okay, so this gives me the expected value of, so this is ex squared, right? Because what did we say? Ex squared is equal to this summation, right? So it's p times that. So expected value is equal to p times 2 minus p over p cubed. So it's 2 minus p over p squared. And now we can calculate the standard deviation. So standard deviation of x is equal to, I'll just do this right away, over p squared, squared, minus, oh no, not squared, minus our e to the e of x. So this is 1 over p squared. So we get 2 minus p minus 1 over p squared. So we can pull out the 1 over p in front, square root of 1 minus p. And that's basically what we end up having. 1 over p times that for the standard deviation. So notice how these are not necessarily the easiest things to calculate. And this is one of the hard things with these things. So what do we get in our example? So in our example, standard deviation of x, so p is equal to 1/6. So we end up getting standard deviation of 1 over 1/6. So this is 6 times 5/6, basically. So if we run this out, we get 5.477. That's it for our standard deviation. So notice how these things aren't necessarily the easiest things to calculate. So yeah. So we'll stop this video here. I'll give another example, an easier example in the next video.